In general, a conductor may contain several different kinds of moving charge particles and having charges Q1, Q2, and so on, and concentrations N1, N2, and so on, and drift velocities with magnitudes VD1, VD2, and so on. The rate of flow of charge out and at one end of a segment at any instant equals the rate of flow of charge and in at the other end of the segment, and the current is the same at all cross-sections of the circuit. So the in and out of the current is just the same, and the current is also the same in all cross-sections of the circuits. When we say cross-sections of the circuits, this is what cross-sections means. And this is an area of the circle. This is why current density I is highly related to the area or the cross-sectional area of the wire. For learning activity 2.1, current density and drift velocity in a wire. An 18-gauge wire, copper wire, this is usually used for the lamp cords. When we say gauge, yan yung taba ng ating copper wire. With a diameter of 1.02 mm. So, yung diameter ng ating individual wire is 1.02 mm. Kasi yung ating copper wire is composed of maliliit na copper wires. So, kapag pagsusumahin or kapag tinitingnan nyo yung mga wire natin sa bahay, ang term is 18 gauge instead of the diameter of the wires. So, the individual diameter of our wire is 1.02 mm that carries a constant current of 1.67 ampere to a 200-watt lamp. The free electron density in the wire is 8.5 times 10 to the positive 28 per cubic meter. Find the current density and the drift speed. Current density, again, is related to the area of the copper wire. So, the area of our copper wire is equals to pi d squared over 4. So, the diameter D is equals to 1.02 millimeter. And the milli is just equals to 10 to the minus 3. 1.02 times 10 to the minus 3 meter. To the power of 2, and that is equivalent to 8.17 times 10 to the minus 7 meters squared. Now, the magnitude of the current density is just J equals I over A. I is the current and A is the area. So, the current, given siya na 1.67 ampere over the area. So, ang current density natin is equals to 2.04 times 10 to the 6 to the positive 6 ampere per meter squared. Now, for the drift velocity magnitude, the VD, the drift velocity, from this equation, we can get the VD. Okay? We can get the VD. Now, by doing so, siguro yung iba sa inyo hindi pa alam paano i-convert ito siya na formula. So, ayan. Ito, since J is just equals to the current over the area and also equals to N QVD, we can get the drift velocity in relation to these two. Okay? We can get this in relation to this one. So, our N, Q, and VD, given ba siya sa problem? Merong N. Electron density of the wire is 8.5 5 times 10 to the minus 2. And the Q is the charge. Okay? So, ang charge natin is okay, so since hindi given si charge natin, ang alam natin sa electron ay mayroong charge na negative 1.60 times 10 to the minus 19 coulomb. Tandaan nyo na yan ha. Si electron ay mayroong charge na negative 1.60 times 10 to the minus 19 coulomb. Okay? So, ang target natin is paano siya naging ganito. Okay? Balik tayo. So, J is equals to I over A equals to NQVD. Now, we have now the value of J. Okay? Kasi nakuha na natin yung I and A. So, si current density J is equals to NQVD. To get the VD, you just need to divide both sides by NQ and NQ. Now, we can cancel the NQ in here. And ang matitira na lang is si ating VD. Now, the VD is equals to the J over N times Q. So, always remember na si charge Q is an absolute value. It may be negative or positive, but the value is always positive. So, I'm sorry. Let's continue. Ngayon, nakuha na natin si V is equals J over NQ. Then the drift velocity, so the drift velocity is equals to the current density, 2.04 times 10 minus to the power of 6 ampere over m squared. And the electron of N 8.5 times 10 to the positive in the electron density of the wire. The N of 8.5 times 10 to the 28 meter cube times the charge of the electron, negative 1.60 times 10 to the minus 19 coulomb. By inputting this into a calculator, you can get 1.5 times 10 to the minus 4 meter per seconds. Evaluation: at this speed of an electron would require 6,700 seconds or almost 2 hours to travel 1 meter along this wire. And the speed of random motion of electrons are roughly 10 to the 6 meter per second and around 10 to the 10 times the drift speed. So, ang tinutukoy lang naman ng drift speed dito is yung ating speed ng electron. Okay? So, the free electron has this speed of 1.5 times 10 to the minus 4 meter per seconds. Let's proceed to next chapter, lesson 2.2, electrical resistance. The current density J in a conductor depends on the electric field E and on the properties of the material. In general, this dependence can be quite complex, but for some materials, especially metals at a given temperature, current density is nearly directly proportional to electric field, and the ratio of the magnitudes of electric field and the current density J is constant. This relationship is called Ohm's law, and it was discovered in 1826 by the German physicist George Simon Ohm. Sino siya? So, ito si George Simon Ohm. Next. We define the resistivity ρ of a material as the ratio of magnitudes of electric field and current density. So don't be confused kasi minsan si Greek letter ρ is ginagamit as a density, but in our lesson, it is used as a resistivity. Okay? So resistivity is equals to electric field over the current density. The greater the resistivity, the greater the field needed to cause a given current density, or the smaller the current density caused by a given field. Okay, na-imagine nyo ba na kapag malaki si resistor or malaki yung resistivity, ibig sabihin nun maliit si current density. Okay? Pag malaki si resistivity, maliit si current density. They are inversely proportional. Pag maliit si resistivity, pag maliit si resistivity, malaki ang value ni current density. So, equation 2.4 has the units V times M over A. And 1 volt per ampere is called 1 ohm. Okay? Or 1 ohm. This is the Greek letter of the ohm, or omega. 1 ohm is an alternative with omega, which is an alternative of ohm. So the SI units for resistivity are ohm meter. Okay? Tandaan niyo yan. Ohmmeter. A perfect conductor would have zero resistivity, and a perfect insulator would have an infinite resistivity. But of course, we don't have a perfect conductor na merong zero resistivity because all conductors has its own resistivity. And also, perfect insulator is also very ideal kasi walang perfect insulator because it doesn't have the infinite resistivity. Metals and alloys have the smallest resistivities and are the best conductors. So, since walang perfect conductor, walang zero resistivity, there are only smallest value of resistivities. And what are these? For example, is the conductors of metal. So, silver has 1.47 times 10 to the minus 8. Pinakamaliit compare sa lahat ng ating metals, conductor metals. So, sa silver is a good conductor, or should we say almost perfect conductor. Okay? Now, si alloy. Si alloy, when we say alloy, it is a combination of many metals. So, example, si manganese. Combination siya ni copper, manganese, and nickel. Okay? So, sa kanilang tatlo na alloy, si manganese ang may kumbaga nakakapag-conduct pa ng maganda-gandang maganda-gandang current. But they are all conducting or they are all materials na nagkakonduct ng current. Ito naman si semiconductor. Masyado nang malaki yung value times 10 to the minus 5 compare kay metals and alloys because sabi ko nga semiconductor is acting like a conductor and an insulator. So it is in between conductor and insulator. Next, si insulator. Si insulator, pinakamagandang or almost best insulator is si ating wood. Okay? From this table, si wood. Kasi meron siyang 10 to the power of 8 to the 10 to hanggang 10 to the power of 11 na resistivity.